Hey guys, and welcome back to McArdle Math Academy. In this video we will be talking about an example that involves counting the elements of a set where we are dealing with three sets. So here's the statement of the problem. Let's assume that A, B, and C are sets within some universal set U where the number of elements in that universal set is 100. Suppose also that we have all these conditions on the sets A, B, and C. So we know the number of elements in A, B, and C. We know how much is in the intersection of A and B and C, A and C, and we also know the number in this large set here, A intersect B intersects C's complement. And the two questions we have to answer. One, let's complete the Venn diagram. I'm going to explain more about what this means in a second. And the second, we need to find the number of elements in this set that's described here. And again, we'll talk about that more. So the first step is to actually create the Venn diagram, draw it. We have our three sets, A, B, and C. And what I've done is I've labeled each of the 8 different regions within this Venn diagram. 1, 2, 3, 4, 5, 6, 7, and 8. So 1 represents the number of elements that are in that exact region there. So only in the region that 1 has within A here. And 2, likewise, etc. So our job is to find the number of elements in each of the regions 1 through 8. And when we do that, we have successfully completed the Venn diagram. So that'd be part A. So how can we find the values of 1 through 8? Well, what I've done here is I've redrawn the Venn diagram from the previous slide, and I've also rewritten the conditions given to us in the problem. What I'm going to do in the second column of the chart here is translate each of these conditions to be a condition that involves the numbers 1, 2, all the way through 8. So for example, this means that the number of elements in A is 40. If you zoom in here and look at the Venn diagram, you'll notice that A is comprised of the regions 1, 2, 4, and 5. So I'm going to rewrite n of A equals 40 in terms of 1, 2, 4, and 5. So if the number of elements in A is 40, that means that 1 plus 2 plus 4 plus 5 must be 40. And I'm going to do the same thing for B and C, and I'll write that here. Now similarly, we can fill in the rest of the chart. For example, A intersect B. If you look at A and B on the Venn diagram up here, the intersection of those two circles is the region that's comprised of 2 and 5. So if A intersect B has 25 elements in it, that means that 2 plus 5 must be 25. So I'm going to fill in the rest of the chart like this, and I'm going to leave this last condition empty for the moment. Now, to fill in the final row, we need to get a better sense of what this set, A intersect B intersect C's complement, actually looks like. So I'm going to zoom out here. Let's zoom in down on this Venn diagram, and let's try to get a sense of what that set looks like. So if you recall a previous video that I created about Venn diagrams, what we're going to do is we're going to shade this, and I'm going to shade B with red, I'm going to shade A with blue, and I'm going to shade C complement with green, and let's look at what we get after that. So here we have it. Now, since we're looking at an intersection, we need to find the region on the Venn diagram that has elements of A and B and C's complement. So since we're dealing with the intersection, we have the word and therefore we're looking at the overlap of all three colors. I need to see blue, red, and green all at the same time. And I'm going to highlight that in purple here. It's just this small wedge right in the middle. All right, so that's what that set looks like. And now I can go back to my table at the top to see what this means for our particular problem. So in terms of this table, remember that wedge is just right in here, and it corresponds to the region labeled with a 2. And therefore, if this set has 10 elements in it, that means that the region 2 is exactly 10. Okay, so I filled in all of these conditions, and I also have one final condition from the problem that I forgot to write down, and that's that the number of elements in the entire set is 100. Okay, and I'll explain where that comes into play in a second. But in any case, let's check this out. I have that 2 is equal to 10, so therefore I have one of them already, and this creates a domino effect, and I'm able to find all of the remaining values just from that one value. And what I mean by that is the following. If 2 is 10, look at this equation here. 2 plus 5 is 20. If you think about that for a second, that means that 5 is 15. So all I'm doing is inputting the 2 into that equation, solving for 5. Now if 5 is 15, check out this equation. That means that 6 is 9. All right, and I can keep on going down the line. Check out this equation here. 4 must be 7. Okay, it gets a little bit trickier as we get up to these top equations. I have 4, 5, and 6, and I can find 7 with this equation here, and likewise I can find 3 here and 1 in this equation. So I'm going to go ahead and do that. You guys can check it for yourselves. So here are the values, 1 through 7. And now the only other value that I have to find is 8. And remember where 8 is located? 8 is on the outside here. And that's where this piece of information comes into play. We know that there are 100 total elements in the entire rectangle. And so to find the value of 8, I have to subtract from 100 the sum of all of the values 1 through 7. So notice on here 1 through 7 are inside of this region. To find what's outside, I just take 100 and subtract all of these values. All right, and when I do that, I'm going to get 44. And there we have it. Those are values 1 through 8, and we have successfully completed the Venn diagram. All right, our final step is to wrap it up, and that involves looking back at what we were actually asked. We were asked to first complete the Venn diagram. Well, we found the values of 1 through 8, so we have successfully completed the Venn diagram. But we were also asked to find the number of elements in this set. And since we have a completed Venn diagram, that's a pretty easy question to answer, provided that we understand what this set looks like. So that's the only part of this problem that we have to finish. Let me zoom out here, and let's zoom in down on this Venn diagram to answer the question about what this set actually looks like. And again, what I'm going to recommend doing is shading the Venn diagram. With a set like this, it's a little more complicated. So first I'm going to shade A union B union C. And I'm going to shade that with red. Of course, that's not the set we're looking for, but that's a set that will help us find the set we're looking for. And A union B union C is this region here. Any elements that are in A or B or C. The set we're looking for is the complement of this set. And I'm going to draw that in green. So I'm going to draw this whole set in green. And the complement is just everything that's not in red. So everything on the outside here. So that's precisely what our set looks like. And if we go back to our Venn diagram, if I want to find the number of elements in that set, I recognize that that set is precisely represented by the number 8. And we already found that 8 has 44 elements in it. So that's the answer to that question. There are 44 elements in that set. All right. And there we have it. We've answered both questions. And I hope this helps, guys. I'll see you next time.